you software developers, welcome to the Deep Dive. Today we're tackling something that should really be squarely on your radar.
Yeah, definitely. We're talking about the way generative AI is getting integrated, like, everywhere. In your workflows, sure, but increasingly into actual applications you build.
Exactly. And that explosion of possibilities is leading to these interconnected networks of AI agents doing all sorts of tasks automatically.
Right. But, as we build these more complex, more connected systems, we get new security challenges, big ones.
Which brings us to today's sources. We've got this really fascinating research paper plus a website they shared with Wired.
And it details a brand new kind of cyber attack, one specifically targeting these AI-powered systems. They're calling it the AI worm.
Okay, let's unpack that right away. This isn't just theory. The research is from Ben Nassi at Cornell Tech, Stav Cohen from Technine in Israel, and Ron Bitton at Intuit.
And the name they chose, Morse the Second.
Yeah, that definitely rings a bell for anyone familiar with cybersecurity history. A clear nod to the original 1988 Internet worm, right? And the Cornell connection, of course.
It's deliberate, but what's really groundbreaking here is how these things work. These AI worms, they're designed to spread automatically.
Automatically, between these Gen AI agents.
Exactly. Think of it like a digital contagion, self-propagating. It jumps from one AI component to another, and critically, without needing a human to, click anything.
Okay, so our mission today, especially for you developers listening, is pretty clear. We need to get under the hood of these AI worms.
Yeah, how do they actually function? What are the specific risks you need to be really aware of when you're building with Gen AI?
And most importantly, what can you actually do about it? What practical steps can you take now to stop these from becoming a massive headache down the road?
So let's start by painting the picture. What's the environment these worms are designed to hit? The researchers really highlight this trend you're all seeing of embedding Gen AI everywhere.
All right, we're moving way past simple chatbots now.
Way past. We're creating these complex, interconnected networks, ecosystems, really, of AI agents that are designed to work together, collaborate.
Okay, so for developers listening, when the researchers talk about a Gen AI ecosystem, what should we picture?
Good question. They define it pretty precisely. It's an interconnected network of what they call Gen AI-powered agents.
And the agent itself, what's the key part of that definition for us?
The agent is basically any application you build that interfaces with two things. First, Gen AI services could be local, could be cloud API, doesn't matter.
Okay.
Second, it interfaces with other Gen AI-powered agents in that same ecosystem.
Got it. So they're designed to talk to each other, pass information back and forth.
Exactly. Using AI to process data, make decisions, coordinate, and there's this sort of inherent trust built into those interactions.
Yeah, and that trust is what can be exploited if one agent gets compromised.
Precisely. That's the vulnerability. Look at the examples in the Wired piece.
Right, they mentioned AI agents booking calendar appointments, maybe even buying stuff for users.
Yeah, and even the VA, the Department of Veterans Affairs, exploring AI for writing code. That's pretty significant.
So this isn't science fiction. These interconnected systems are being built and deployed right now.
Absolutely. And it's that growing interconnectedness, that increasing autonomy, that really expands the attack surface. It creates the opportunity for these AI worms.
Okay, so let's get to the core threat then. What exactly is an AI worm, and how does it operate in these ecosystems you're building?
The researchers identified this key mechanism. They call them adversarial self-replicating prompts.
Adversarial self-replicating prompts. Okay, that sounds technical. Break that down for us in developer terms.
Think of it like this. You craft a very specific input, a prompt. When you feed it to the Gen AI model, it doesn't just give a normal answer. Instead, it's engineered to trick the AI, to make it include another prompt, an equally malicious one, inside its own response.
So, the AI basically replicates the bad instructions as part of its output.
Exactly. It looks like a natural response, but buried inside is the code to infect the next thing it talks to.
Okay, so the prompt basically tells the AI, hey, when you reply, make sure you include another copy of me.
That's the essence of it, yeah. The article draws some really good parallels to cybersecurity threats we already know well.
Like SQL injection, maybe, or buffer overflows.
Spot on. Think about SQL injection. You embed malicious code inside what looks like normal data to trick a database.
Right.
Or buffer overflows, where you write data past its boundary to overwrite code. These AI worms, they use a similar principle, but for language models.
The data is the prompt you send in.
And the attacker tricks the AI into outputting code in the form of another self-replicating prompt. Data becomes code, but inside the LLM's response.
Wow. Okay, that fundamentally changes how you have to think about input validation, doesn't it?
Totally. It's not just about data types or formats anymore. You have to ask, could this seemingly harmless input manipulate the AI's output to generate a payload somewhere else?
That SQL injection analogy is really helpful for developers. And the article stresses these are zero-click worms. That sounds particularly bad for autonomous agents.
It is. Zero-click means no user interaction needed, like clicking a bad link or opening a dodgy file.
So how does it spread then?
Because these GenAI services often automatically process inputs, sometimes even act on them, the worm spreads just by being processed by the AI. The initial input hits the AI and bam, it can start propagating. No end-user click required.
And the researchers were clear. In their tests, the applications weren't already compromised. They were vulnerable just by receiving that crafted malicious input.
That's a huge architectural point for anyone designing these systems. It's an inherent vulnerability based on how the AI processes information.
Absolutely critical. It really shines a light on a totally new attack vector that you developers need to consider right from the start, from the architecture phase.
So how did they actually show this worked? What were the practical demonstrations?
They focused on GenAI-powered email assistants. Made sense. And they showed two main attack methods. First was a text-based self-replicating prompt.
Okay, walk us through that one. How did the text attack work?
So the attacker sends an email containing this malicious text prompt.
Right.
The email assistant uses RGAD retrieval augmented generation.
Which is like giving the AI access to a knowledge base, like your emails, to answer questions better?
Exactly. So when that malicious email gets ingested, it essentially poisons that knowledge base.
Okay, I see where this is going.
Then later, a user asks a question. The system might pull up that poisoned email as relevant context.
And the LLM processes the user's question plus the hidden malicious prompt.
Bingo. And that can lead it to leak data from other emails it can access.
Uh-huh.
And, crucially, it embeds the self-replicating prompt in its answer back to the user.
So the infected reply goes out, potentially containing stolen data and the worm itself.
Yeah. And that reply might get stored, used in future interactions, maybe even used to automatically reply to emails from other people, spreading the worm further.
Wow. So it's not just data theft, it's propagation built in. Nasty. What was the second method? You said images.
Right, embedding the prompt within an image in an email. This uses the multimodal capabilities of newer LLMs, the ones that can understand images, not just text.
Okay, that's clever. How does embedding it in an image work?
By crafting the image just right, they could trick the email assistant into automatically forwarding the entire email, including the malicious image, to other people.
Ah, so it becomes a vector for spreading spam? Or worse?
Exactly. Spam, abuse material, propaganda, potentially on a massive scale, all triggered just by the AI processing that initial email with a hidden image prompt. 0 user clicks needed after the initial reception.
And they tested this against the big names.
Yep. The paper says they successfully hit ChatGPT 4.0, Gemini Pro, and even the open source LLaVIE model.
So it's not just one specific model's flaw. It seems like a more general issue with how these models can be manipulated through prompts.
It looks that way.
Yeah.
And the potential consequences they highlighted are serious, especially if you handle sensitive data.
Like what? Data exfiltration.
Yeah. Names, phone numbers, credit card details, social security numbers, all potentially exposed. Plus the mass distribution of spam or harmful content we just mentioned.
Okay, but this was all in a lab, right? A controlled environment.
It was. That's crucial context. But the researchers themselves, they seem pretty convinced this isn't just a lab curiosity.
What did they say about real-world potential?
They believe AI worms like this could realistically show up in the wild within the next 2 to 3 years. 2 to 3 years. That's soon. Why so fast?
They point to how quickly these GenAI ecosystems are being built into everything. Cars, smartphones, operating systems. The integration is happening incredibly fast, creating the environment for these worms to thrive.
The Wired article also brought in other experts. Zico Coulter from CMU and OpenAI had some warnings.
He did. He pointed out the inherent dangers when you let AI agents interact autonomously, and he stressed the need for models that are just fundamentally more resistant to these kinds of attacks.
Makes sense. And Sahara Delnavi, another researcher.
She's an expert on prompt injection. She basically confirmed the plausibility, especially in apps where AI models ingest external data like emails or web content, or where they operate autonomously.
So while it's lab-based now, the underlying mechanics seem sound, and the conditions for it are rapidly developing.
That seems to be the consensus, yes. This might not stay theoretical for long.
Okay, so for all the software developers listening right now, this brings us to the really critical part. What can we actually do? How do we mitigate this?
Right, the practical steps. Well, first off, don't throw out the basics. Traditional cybersecurity best practices are still your first line of defense.
Absolutely. Input validation, security headers, all that good stuff.
But with Gen AI, you need more. There are specific considerations. Adam Swanda from Robust Intelligence had a really key piece of advice.
What was that?
He basically said, and I'm paraphrasing slightly, you typically don't want to be trusting LLM output anywhere in your application, not without careful validation and sanitization first.
That feels like a core principle for developers working with LLMs now. Don't blindly trust what comes out.
Exactly. If the LLM can be tricked into generating malicious prompts, you can't just pipe that output directly into other parts of your system without checking it.
So validate and sanitize LLM outputs. What else?
Keeping a human in the loop, especially for critical actions.
Can you give an example?
Sure. Say you have an LLM reading user emails. Don't let it just automatically send emails based on what it reads. Require explicit user confirmation for each outgoing message.
Create a boundary. Prevent autonomous actions that could spread the worm or cause harm.
Precisely. That human oversight is a powerful break.
They also mentioned monitoring, looking for patterns.
Yeah, monitoring for repeated or unusual prompts within your Gen AI systems. A worm trying to replicate itself might generate telltale patterns.
So anomaly detection could potentially spot this kind of activity.
It could play a role, yeah. But ultimately, the researchers stress the need for a mindset shift. Awareness. You need to build awareness of these new kinds of risks right into your design and development process from day one. Think about these AI native threats proactively.
Okay, and how is the industry itself reacting? The researchers told Google and OpenAI, right?
They did. OpenAI acknowledged the research. They said it looked like an exploit of prompt injection vulnerabilities stemming from unchecked user input.
And are they doing anything about it?
They said they're working on making their systems more resilient and advise developers, again, to make sure they aren't processing harmful input.
Okay, and Google?
Google declined to comment publicly for the article, but interestingly, they did ask for a meeting with the researchers.
Which suggests they're taking it seriously internally, even if they're not commenting yet.
You'd assume so, yes.
But the researchers themselves, they made a point about responsibility, didn't they? It's not just on OpenAI or Google.
No, and this is really important. They argued that while model robustness matters, a huge part of the problem is what they called bad architecture design of the Gen AI ecosystems themselves.
Meaning how developers like us actually connect these agents together.
Exactly. How they're interconnected, how much trust is implicitly assumed between them, how much autonomy they're given. That's where a lot of the vulnerability comes from in their view.
So wrapping this up, the big takeaway for software developers is, well, the game is changing. AI worms are a real emerging threat.
Yeah, the cybersecurity landscape is shifting fast with Gen AI. We're moving beyond just traditional vulnerabilities into this new class of AI native threats you need to prepare for.
Which means secure application design, being really skeptical about raw LLM outputs, and thinking very carefully about autonomous AI actions. These are becoming absolutely critical.
Paramount, especially as you build more and more AI features into your apps and workflows.
So that leaves us with a final thought for you, the developer listening. As you build these features, as you integrate more AI, how are you proactively thinking about defending against threats like AI worms?
What boundaries are you actually building into your systems to prevent these kinds of unintended, potentially malicious autonomous actions?
It's a crucial set of questions to be asking yourselves right now.
Absolutely. And if you want the deep technical dive, really get into the weeds, we definitely recommend checking out the actual research paper and the website they shared. It's fascinating stuff.
Definitely worth a read. That's all the time we have for this deep dive. Thanks for joining us, and stay secure.